When you upload a photo, where does it go? Not into a folder. Instagram holds hundreds of billions of photos, and every like, every comment, every account, every message ever sent. If that were a pile of files, finding your feed would mean searching through all of it every single time you opened the app. Nothing would ever load. So there's something else doing the remembering. Something built for one job, hold an enormous amount of information, and find any single piece of it instantly. That's database. This is System Design from Zero, episode 4. Start with the obvious question. Why not just use files? For 10 users, files are fine, one file each. For 10 million, it falls apart for 3 reasons. First, finding things. To answer, show me every post by this person, you would have to open every single file and check. Second, changing things safely. If 2 people like the same photo at the same instant, both read 41 likes. Both write 42. One like just vanished. Third, relationships. A post belongs to a user. A comment belongs to a post. A like belongs to both. Files don't know about any of that. You'd be tracking it all by hand. A database solves these 3 problems. That's really all it is. A program that stores information and is very good at these 3 specific things. So what does information look like inside one? In the most common kind of database, it looks like a spreadsheet. A table has columns, the kinds of things you are storing. For users, an ID, a name, an email, a join date, and rows. One row per actual user. Row 1, ID 1, Sarah, sarah@gmail.com, joined in March. Row 2, ID 2, Tom. Every user is one row. Every post is one row in a different table. Every like, one row. That's it. That's the shape of most of the world's data. And notice the ID column. Every row gets a unique number, and that number is how everything else refers to it. A post doesn't store Sarah. It stores user ID 1. That's how a database knows a post belongs to a person. It's just a number pointing at another row. Now, how do you get anything out? You ask in a language built exactly for this. It's called SQL, and it reads almost like English. Select star from users, where name equals Sarah. Select star means give me everything from users. That's which table. Where name equals Sarah, that's the filter. Give me everything from the users table where the name is Sarah. That's a query. And that's genuinely most of what people write. You can also ask for combinations. Give me every post where the user ID is 1 ordered by newest first, and stop after 20. That's your feed. That single sentence is what the machine runs when you open the app. A database can answer that across a table with 100 million rows in a few milliseconds. Which brings up the obvious question: how? Say you have 100 million users and you are looking for one email address. The slow way is to check every row until you find it. That's called a full scan. And on 100 million rows, it's exactly as slow as it sounds. Now, think about a book. If you want every page that mentions gravity, you don't read the whole book. You flip to the index at the back where every important word is listed alphabetically with its page number. A database index is the same idea. You tell the database, keep a sorted list of every email address alongside where that row lives. Now, finding an email doesn't mean checking 100 million rows. It means a handful of jumps through a sorted structure. 100 million rows and it lands on the right one in about 27 steps. This is the single biggest reason database feel instant. And it's the most common reason a slow app is slow. Someone forgot to add an index. So now you have a machine that answers requests and a database behind it doing the remembering. That's a real system. It works. But look at what everything now depends on. One database. Every request from every user or every page ends up at that one place. And if it slows down, everything slows down. If it runs out of room, everything stops. If it fails, your entire app is gone. Not slow, gone. The most important thing in your system is now also the most fragile. Next episode, we take this whole picture, the machine, the API, the database, and do something to it that every real system does. We make it survive success. Next episode, what happens when your app suddenly gets popular and why one server is never enough. This is System Design from Zero, one idea at a time. See you in episode 5.